Okay, I'm going to start today with a couple of slides and just a reminder about functions, Python functions. So Python functions, we did this example last class where we defined a function and we used the def command. We can use any name. Here we've used f of x to name the function. And then I explained that we want usually to have a little bit of explanation of what the function does. This is called a docstring, is what is shown in red here in the syntax highlighted text. And the docstring is like a short little help page, or the manual, if you will, the user's manual of this function. You want to usually have a statement about what the function does. Then you want to have the list of arguments. The arguments would be the input to the function. As you can see here, the name of the function is f, the input is x, and that is in parentheses. And here we have in the list of arguments, x is the input, a number. I have a typo there. And then we usually want to list what is the output of the function, what it returns. In this case, it returns y. Here it is, return y, and y is the result of calculating some polynomial of x. And this is a simple function that we used last time. So let's go back to a Jupyter Notebook. So everybody log into Jupyter Hub and review a couple of key points about functions that sometimes cause some difficulty when you're just beginning to learn. So let me go now to Jupyter. And here is my set of notes for the class. I'm going to start a new Jupyter Notebook for today. And this one is just going to be a short little review of some functions, some issues with functions, okay? I'm going to give it a name, and I'm going to today's class 11 for us, notes. I might just say here functions, just to be specific. This is what is in this notebook, so it's easy to find later on if you want to review this material. And I am going to toggle the header there to have more space. So we're going to start with a markdown cell just to put a title here about Python user-defined functions. I say user-defined to distinguish with the built-in functions, right? Python has many built-in functions that we take advantage of. The easiest of which is the print function that we learn in the first class with Python, of course. And what characterizes, you know that it is a function because it takes arguments in the round brackets. And the user-defined functions are what gives you so much flexibility to create code that you can reuse over and over again. So it makes sense if you've already solved some problem with Python to reuse that code in future applications. So let's just import NumPy to start with. We're going to use a little bit of NumPy, but not much. And imagine that we have a very simple function. Let me call this function add5. Okay, it's a function that takes in an array as input. At the end of our definition line, we have a colon, and we enter the block of code that should be part of the function as an indented code right after. Normally, we would have here triple quotes, 1, 2, 3, single or double to write the docstrings. I'm just going to say here, this little function adds 5 to the input. All right, I'm going to keep it simple to save some space here, but normally, as I said, a function, we would like to list the arguments right here and the return value. So let's suppose that inside this function, I define a variable n equal to 5. So I assign the value 5 to the variable name n. And let's suppose now that I'm going to return the array that came in plus n. Okay, notice here that I am able to do a calculation in the line that has the return statement. Many times we create a variable in an intermediate variable name. I could have saved it new array is array plus n and then return new array. I could do that. And then sometimes if the calculation, the function is a little bit more complicated, For readability, you might do that. Or if you need the intermediate variable new array in the function itself, you will have to assign it and then you return it. But you can also return something that is computed right then and there. So let's execute this line now, and that defined the function. Nothing happened, we don't see anything, but it defined the function. So if I do type add 5, Python tells me it's a function. Add 5 is a name that Python in this session understands to be a function. And so of course I can define an array. Let's call it ARR1 for array 1. And let's use a NumPy function to create an array, just the function arange, which will give me integer values from 0 to 5, but not including 5 in this case. And let's say that I'm going to, okay, so let's enter a line here and print it just for kicks and see it. There it is. Array 1. And I'm going to now define an array 2 that is the return value of applying the function add 5 to array 1. Now, I want you to pay a little attention here because this seems simple, but sometimes can trip you as a beginner. We are calling, this is the language that we use is we're calling the function here, just like we call print. I call the function print in this line. I'm calling the function add 5 in this line. And I pass the argument ARR1. And once the argument comes into this function, inside the function, it takes the name array. When I defined in input line 2 the function, the name array is a temporary placeholder for the parameter that will come into the function when it is called. In this input line, I am calling, and then the return value from this function, which is array plus n, will be assigned here to the new array ARR2. So a lot of things are happening there, even though it looks simple. So that's what we need to pay attention. So first thing to notice about this example, what will happen if I now print or want to print the variable n? You see n is there. What will happen? Think about it for just 1 second before you execute this. I'm going to execute it. Oops. A name n is not defined. We have an error. Python is not happy because name n is not defined. The reason for this is that here we've defined n inside the function. This is called a local variable. It only exists temporarily inside this function when we call it, but once we return from the function the result, n no longer exists as a name and no longer has a value. So that's why I get this error, name n is not defined. N is a local variable. The variable n is called a local variable. A local variable is not accessible from outside the function, okay? And that is important. Very important to think about when you're learning about functions. Okay, I'm going to add a couple of cells there so I can scroll a bit. So what if I have the variable n, okay, defined outside the function, but let me give it a value, a different value, a value of 10 and execute that. That defines n now outside of the function and it's available. Now, if I do print n, of course, I obtain 10. Now think about what might happen now if I call the function after this. Again, let's suppose I create another array and I'm going to say array 3 is now numpy.linspace. I'm going to go from 0 to 10, stepping by 5, maybe by 2. I execute that, and now we have array. Before we print that, think about what is the highest value of array 3. Think about it a little bit, and now let's print it. All right. What happens if I think I misspoke here because I said step by 2, and in linspace, what we're really saying is the number of elements that we want. Okay, so I misspoke there. The array 3, now I can also feed that to my function in a call. So let's do array 4 is, what did we call, add 5, and I'm going to use as argument array 3. And now, well, you might think I am going to execute this function inside the function n takes the value of 5. So you may ask yourself, what is the value of n after I call this function one more time? And the answer is, it's still 10. It's still 10 because now n is a global variable, has the value 10. When we go into the function, the local variable, doesn't matter what name it has, it still disappears once you exit the function, once the function returns its value. So this is something that can confuse beginners, and so something you need to keep an eye out, the idea of global variables and local variables. Okay, so what if we were to do something different? Let's suppose now that I define another function that is similar to the one I had before, but I'm going to say the function is a function that is going to add not 5, but k, and I don't know what k is, to an array that comes in as an argument to the function. Okay, this function, triple quotes to write my doc string, single or double quotes is the same. This little function adds k to the input. Let's just say that to keep it simple. Let's suppose now that I say, okay, this function was going to return, similar to before, it will return array plus k. Now, you will notice that in this function here, I'm saying array plus k. K is not defined here as a local variable. K is not defined outside as a global variable. So it should give me an error, you might think. I execute that, no error. Why is there no error? Well, when I define the function, Python thinks that you know what you're doing and you're defining your function and it defines it for you. And then the problem arises when you call the function. So if I were to try to call this function add k with any of the arrays that we have created, let's use array 1. And now if I execute that, it's going to give me an error because now is the time when the code inside of the function is first executed. When I define it, it's just like you write it into memory, what the steps are going to be. You're writing down the recipe, but you're not yet executing. Once you execute the recipe, you might find that some ingredients are missing. Before you execute, it's just written and you don't realize. So notice that message right there that we received. And this happens quite a bit, and it confuses you sometimes because you might not immediately see where the error is coming from. So the message here is that k is the local variable. K is not defined inside the function. And you get an error the first time you call the function, not when you define it. Okay, so that is important. Now, okay, so the final example. Now let's assume that we do define k. So let's define k is equal to 20. Okay, now k is equal to 20. K is not defined inside the function, but it is a global variable. So what will happen now if I try to add k to my array 1 or any array? What do you think will happen? Think for a moment, then execute that and see that happily a result was returned to you where the array 1, remember that array had 0, 1, 2, 3, 4. Well, right, so no problem, it added 20. So the variable that is defined outside a function is available to the function for using it. Now, this is the case, but it is not very good form to use global variables, and you should be careful with that. So these are some notes to remember, these little tips. A variable defined inside a function is called a local variable and is not accessible from outside. A variable name that is inside the function won't affect any variable outside. So you may even reuse variable names and it's no problem. The global variable is not affected. But what happens inside the function? Python is not going to complain about undefined variables until you call the function. So sometimes you write a function, you will get no errors. Many times other types of errors could be present in the code inside the function, but you will not see an error when you define the function. You will see the error when you call it for the first time, because that is when the code is going to be executed. And finally, a function should be self-contained, and it is good practice to always define variables inside or pass through arguments. And if we're using global variables, you should be careful and know that that's happening. This topic is usually called variable scope, the scope of a variable, whether it is local or global. And it is a topic of programming that can trip you often as a beginner. So I wanted to overview that. Any questions about this? Let me look at the chat now to see if there are any questions. The opposite is not true, correct? A variable name used outside a function would affect any variables inside. Okay, so let's go back to the example. And let's see here. K is 20. That was defined outside. And let's see in this example here, N is 10. Right? And I said print n, and out comes 10. Then inside the function, if I add, let me add a line here. So let me add a cell. Let me print the input, which is array 3, excuse me. And let's also print the result, which is array 4, and execute that. Notice what happened here. Array 3 has 0 and 10. Array 4 has 5 and 15. So by executing the function add 5, we added 5 to each element in the input array. Even though n outside has the value 10, inside the function, it still has the value 5. So the name outside of the function does not affect the value inside of the function. The function is self-contained. Any variables you define inside as local variables are used inside the function, and then poof, they disappear after you exit the function and return the value. I hope that answers your question. Good. It sounds like it did.